My name is Shriya Bansal and I'm currently working as a software engineer at Microsoft, and I'm also an educator at Level. So in this video, we are going to move forward and talk a little bit about database management systems, database models. Okay, so that means we'll first define what a database model is, and then we'll classify it into 4 parts. Okay, and then we'll take a look at each of them in detail. So let's quickly get started. So a database model basically defines the logical design and structure of a database and defines how data will be stored, accessed and updated in a database management system. So now you have a lot of data. Now in that lot of data that you have and you store it in a database, there are logically lot of designs and structures that you can give to a database to actually define how the data will be stored, accessed and updated. Okay, out of all the 4 methods which are available, the relational model is actually the most widely used database models. Okay, I'm telling it in the very start itself that out of the 4 which are available, the relational one is the one which is most popularly used and which we will take a look at towards the end as well. But apart from that, there are other 3 available as well, which we will take a look at. The all 4 are: first is the hierarchical model of logically designing a database, then is a network model, then is an entity relationship model, and then we have the relational model. Okay, so let's take a look at all of them in detail and understand how do they really work. So this database model basically organizes data into tree-like structure. So there's the name hierarchy over here, right? So there's like hierarchy. Something is going to be at the top, then this is going to have a child, and then the hierarchy spreads out. So this database model organizes data into a tree-like structure with a single root at the top to which all the other data is basically linked. Okay, so it's usually having a parent-child kind of like a relationship where there's one person at the top and everything gets spread in the bottom. So like it says, the hierarchy starts from the root node and expands like a tree, adding child nodes to the parent nodes. So you keep on adding child nodes to the nodes which are already present. In this model, a child will only have a single parent. So it's not like a child and it's connected to 2 parents. That's not possible. This model efficiently describes many real world relationships like index of a book, recipes, etc. In hierarchical model, data is organized into tree-like structure with one-to-many relationship between different types of data. So one parent can have multiple childs. So this is like a one-to-many relationship. One parent, multiple child. But for every child, there is just one parent. Okay. Now, just to repeat it, in hierarchical model, data is organized into tree-like structure with one-to-many relationship between 2 different types of data. For example, one department can have many courses, many professors, and of course many students, right? If there's like a department of psychology, okay, it can have many courses going inside it. It can have many professors available for that, and many students are enrolled in it. See an example. So there's like a college which is at the top. College has 2 branches over here, 1 or 2 childs rather. One is the department and one is the infrastructure. Okay. Now for department, we further divide it into a department can have courses, a department can have teachers, department can have students. Okay. And that course can have, let's say, theory courses, and it can have labs or practical courses. So this is how you hierarchically design your data, and hence the word comes over here, which is hierarchical model. Okay, everything is organized in a tree-like structure. This is like sort of like an inverted tree, right? A tree goes in the start and then spreads out. This is like an inverted tree where it starts with a single root and then it branches out. Okay, so that is what hierarchical model is. Okay, I hope this is clear to everyone. Next, we are going to talk about the network model. Now, the network model is basically an extension of the hierarchical model. In this model, the data is organized more like a graph, okay, and are allowed to have more than one parent node. So this is not like a tree kind of a structure, it's more like a graph kind of a structure where it's like a network. Okay, it's not like something is starting at the top and then spreading out. It's more like graph. Anything could be linked to anything. Child can have multiple parents, parent can have multiple childs. In this database model, data is more related as more relationships are established in this database model. So it's not like just like a parent-child relationship. You can also have sibling-sibling relationship, right? Both of them have the same parent, right? And many other relationships with that. Also, as the data is more related, hence accessing the data is also easier and fast. Okay. This database model was used to map many relationships. Like I told you, right? Parent can have multiple child can have multiple parents, right? And not just that, it's like two nodes have multiple links available to them. And this was the most widely used database model before relational model actually got introduced. Okay, so you can see here as well that here we have we have B1, B2, it has two childs, right? Although it looks like a hierarchical here as well, but if you really look at it, it could be like this, like A1, let's say connected to B1, B2, C1 connected over here and connected over here, C2 connected over here, C3 maybe connected over here, right? C4 maybe connected over here. So it's like a network. This is what you known as a network model. In a network model, there is no start where, like, you know, the network is starting. There is no root node, right? There's no parent-child relationship. But whenever you talk about hierarchical model, in the hierarchical model, you have like a parent, it has childs, right? A child can only have one parent, okay? It cannot be like that C is connected to this as well. This is not a valid connection, okay? This is where you have the root, okay? Root has basically child, these are the child nodes. Now this becomes the parent node and these are the children, okay? So it's like a hierarchy, top to down you move. Okay, whereas in a network, it's more or less like a network. Let's say you think of like a network of roads, right? It's pretty much like that. Okay. After this, what we have is the entity relationship model. In this database model, relationships are created by dividing the objects of interest into entity and its characteristics into attributes. Okay, so here what we do is we try to have different entities which are present in our database, right? And we try to logically divide them, right? And whatever interest characteristics they have, it becomes the attributes. Different entities are related using relationships. So there's like a school entity, right? In a school database, let's say there's a teacher's entity, there's a student's entity, there's a subject entities, there's a fees entity, right? So teacher is related to subject. So teacher is an entity, right? And the relationship is depicted between teachers and subjects. Okay. ER models are defined to represent the relationships into pictorial form to make it easier for different stakeholders to understand. So actually what happens is we actually define ER diagrams which are a pictorial way to make it easier for everyone and all the stakeholders to understand the relationships between different entities. This model is good to design a database which can then be turned into relational models. So what we do is we take first and we start with an entity relationship model. Let's say if there's a school, we first try to define different entities. For example, subject, right? For example, teachers, for example, subjects, and I think I said student's name, right? Everything. And then when we have like a pictorial representation of everything and we have the ER models, then we convert it into relational model, and it is possible to do that as well. Let's take an example. If we design a school database, then the student, like I said, will be an entity And what attributes will the student have? The student will have a name, the student will have an age, the student will have an address, right? An address is generally complex. Now it can be another entity also, right? Instead of keeping address as an attribute to student, entity can become a separate entity. Address can become a separate entity also with, let's say, street name, pin code, city, and there will be a relationship between all of them. This kind of shows like an example. Okay, we have a student has an ID, student has an age, name, address. Usually we define it like this. So let's say I have to define an ER diagram for a school. For a school, it will have, let's say, student as an entity. Now it will have a name, it will have age, it will have a phone number. Similarly, so this is the entity, and these are the attributes of the entity. Okay, similarly, let's say there is another entity, teacher. Teacher has a name, teacher has an age, teacher has a phone number, teacher teaches a particular subject. Okay, again, this is the entity, and these are the attributes of the entity. Now remember, we can draw relationships over here, right? Now a student can have multiple teachers, correct? So a student has one to many relationship with the teacher's entity. Okay, so that's how the entire entity model works. Next, we will talk about the relational model. Now, what happens in the relational model is that the data is organized into two-dimensional tables. Everything is organized into tables, and the relationship is maintained by storing a common field. You remember we did that, I think, in the previous examples that we took, where over here you can see that there was one table teachers and there was a table subject. And how to draw the relationship between teacher and subjects? There was one common attribute which was present in the teachers table also and the subjects table also. Correct? So that is how we draw the relationship, and that's what it says in the statement as well, right? In two-dimensional tables, data is stored and the relationship is maintained by storing a common field. Now this model was actually introduced by E.F. Codd in 1970, and since then it has actually been the most widely used database model. In fact, we can say the only database model, this is the one which is used around the world. The basic structure of data in the relational model is stable. Everything has to be in a tabular format. All the information related to a particular type is stored in rows of that table. So if I have a student data, everything will go in the students table. If I have a teacher's data, everything will go in the teacher's table. Okay. Hence, tables are also known as relations in relational model. Okay. So that is why, since it's a relational model, tables and relations word is like interchangeable. In the coming tutorials, right, in the coming sessions, we will actually learn in a relational model, how do we design the tables, how do we normalize them, which is used to reduce redundancy, right, and how to use query languages to actually access the data from these tables. So in this course, we are going to use a relational model itself, which I told you is the one which is the most popularly used, and it will look something like this. You can see here as well. So there's like a student table in which we are storing student ID, we are storing the name of the student, and we are storing the age of the student. Then there is a subject table in which we have the subject ID, we have the name of the subject, and we have also stored the teacher who is teaching that subject. Okay, so consider it a scenario where one teacher is teaching one subject itself, and every subject has a single teacher. So Java has the teacher Mr. J, C++ has the teacher Mr. C, and C# has the teacher Mr. C hash, and PHP has also an educator. Okay, and now you can see that the table over here, which is below, is a relationship for what student stored marks in which subject. Let's say I want to store which student stores which marks in what subjects. Okay, so I will use the student ID, I will use the subject ID, and I will have the marks. So using this, I can say the very first line says that student with the ID 1, who is Akon, has scored 98 marks in the subject with subject ID 1 Java. So Akon scored 98 marks in Java. That is what it really means. Similarly, in the next line, we can say Akon stored 78 marks in C++. I hope you can do the third and fourth as well. The third one says that Bcon basically scored 76 marks in Java, and Ccon basically scored 88 marks in C++. So to derive a relationship, now there's very less redundant over here, right? You don't have to write the names of the students again. There's no need of storing the age. You just use the student ID, you just use the subject ID, and using that you made another table to draw the relationship. And that is what we have in relational model. So what we do is, usually when we have figured out over here the ER models, then it's very easy to convert it into relational model, because this nothing means that, or this simply means that there is a table for student where we have the name, where we have the age, and we have the phone. So once you know the ER models now, using that, it's actually very easy to convert it into a relational model. That's what we were talking about in the previous one as well. Okay, so here we have simply used the ER model to convert it into a relational model where everything is stored in terms of tables. All right, and that is what you have to focus on as well, right? In the journey for DBMS, it's very important to understand how we create ER diagrams, how we convert them into the relational model, and how everything works. So just to reiterate on what we did in this video is that first we talked about database models. Now a database model basically defines how logically we are going to design and structure our database and how our data will be stored. We have 4 database models available. We have the hierarchical model, the network model, the entity relationship model, and the relational model. There are some more as well, for example, object-based models as well, but you just have to focus on these ones over here in this video. The hierarchical model is basically like a tree-like a structure. We have a root and we have like a parent-child relationship. Every child has a single parent and a parent can have multiple childs. And the diagram over here explains it completely well. We start with the college. We have 2 parts in it, a department and an infrastructure. The department can have further 3 parts, courses, teachers, and students, right? And then the courses are also further divided. Next, we move on to the network model. This was actually an extension of the hierarchical model, which is less like a tree and more like a graph where everything is kind of connected to each other, right? And that's what we saw over here as well. In the network model, it's like one big network and it's like many to many relationship. One node can have multiple parents and a parent can have multiple childs. Okay. And before actually relational model was introduced, network model was the one which was most popularly used. Then we talked about entity relationship model, where everything or whatever we have in a database, everything is first divided into entities and their relationship is being then represented. Okay, once we have the ER models and the ER diagrams, they are just a very good pictorial way to represent everything, right? And then it can easily be converted into the relational model, right? And that is what it says over here. And I think we drew a perfect example for that as well, where this is kind of like a ER diagram where different entities are shown and the relationship between them is represented. So entity is like an object of interest and its characteristics basically become the attributes. Next, in the end, we have the relational model, which was introduced by E.F. Codd, and it's the one which is the most popularly used. And in this, everything is in tabular format, 2-dimensional tables. And the relationship is being represented by some common fields which we have in tables. Okay? And in the next few classes, we will talk about only how these concepts work. Alright, so I hope this is clear to everyone and I was able to make it a little bit easier for you to understand as well. This is definitely a learning journey. So as and when we'll practice more, we'll get more hands-on on this, we will gain more and better knowledge on how to work on this. Alright, so thank you so much for attending this video and I will definitely see you in the next one.